Hi, I am Ms. Sushma, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering College. In this session, we are going to discuss about the encoders and decoders. So first we are going to discuss about the decoder. What is decoder? Decoder is a combinational circuit that has n input lines and 2 to the power of n output lines. And one of these outputs will be active high based on the combination of inputs present at the decoder input. So when the decoder is enabled, any one of the outputs are going to the high according to the input. So when enable signal, here we have another extra signal enable for the decoder. When enable signal is 0, then all the outputs of the decoder will be 0 when enable is high. So when the decoder is enabled, then any one of the output will be the high according to the inputs. So that means decoder detects a particular code. The output of the decoder are nothing but the minterms of n input variables when it is enabled. Okay. So this is the block diagram of the decoder. It has n inputs and 2 to the power of n outputs. Decoder has the n inputs and 2 to the power of n outputs. So here first we have so many types of decoders, 2 to 4 decoders for n is equal 1. So decoder has n inputs and 2 to the power of n outputs. If n is equal to 1, we have 1 by 2, and if n is equal to 2 by 4, that is 2 inputs, 4 outputs decoder, 2 to 4 decoder. If n is equal to 3, we have 3 to 2 power 3 is 8. So 8 outputs. It has 3 inputs and 8 outputs, 3 to 8 decoder. For n is equal 4, we have 4 to 2 to the power of 4, 16 outputs. So 4 to 16 decoder. Okay. So here first we are going to discuss about the 2 to 4 decoder. In 2 to 4 decoder, here we have 2 inputs and 2 power 2, 4 outputs. And one another signal, enable signal we have for the decoder. So here A1 and A0 are the input signals, Y3, Y2, Y1, Y0 are the outputs for the 2 to 4 decoder, and enable signal is denoted as E here. Okay. So one of these 4 output values will be 1. Any one of the output value either from Y0, Y1, Y2, Y3, in this any one of the output will be high according to the inputs A1 and A0. Okay. When E is equal to 1 only, then this decoder will be enabled. If E is equal to 0, this decoder will be disabled. That is nothing but if E is equal to 1, any one of the output goes to high according to the input. Otherwise, all outputs will be 0. So if we observe this truth table of the 2 to 4 decoder, okay. So here we have inputs A1 and A0 and enable signal, and outputs are Y3, Y2, Y1 and Y0. If enable signal is 0, then decoder is disabled. So here you will get all the outputs are going to get a 0. If enable signal is 1, the decoder will be enabled, and according to the inputs, any one of the output will goes to high. So if it is 0, 0, if A1 and A0 is 0, 0, then Y0 goes to high and other outputs are 0. Okay. If it is 0 and 1, then Y1 will be high, other outputs are 0. If it is 1 and 0, then Y2 will become 1 and other outputs are 0. If it is 1 and 1, then Y3 will become 1 and other outputs are 0. So if we observe the truth table, according to the input, any one of the inputs are going to be high. If it is 0, 0, Y0 is going to be high. If it is 0, 1, Y1 is going to be high. If it is 1 0, y2 will be going to high, 1 1, y3 is going to be high. This is the functionality of 2 to 4 decoder. So from the truth table, we have to convert that into logic circuit. So here, if we observe this truth table, here y0 is 1 when a1 and a0 is 0 0 and e is 1. So it is the min term of the inputs. We have to write the y0 in terms of min terms. If you observe 1, so y0 we can write as this as e. Min term is a product term. So a1 bar and a0 bar. Okay. And y1 is 1 when during this combination. Okay. So that's why we can write y1 is equal e a1 bar, because here 0 we have to write a1 bar. If it is 1 we have to write a1. Okay. And a0. And for y2, this is the combination for the y2. We have to write the min term for this one. Okay. E. This is a1 and a0 bar. And for y3, we have to write enable this combination. Y3 is 1 during enable is equal 1, a1 is equal 1 and a0 is equal 1. So E, a1, a0. So these are the equations for the outputs in terms of inputs. So we have to convert this logic the equation into Boolean equation into logic circuit by using logic gates. So here if you observe y3, so here for y3 the inputs are E into a1 into a0. So for the product we have to use AND gate. For if it is a OR operation, if we are adding the inputs, we have to use the OR gate. So here E1 into a1 into a0. So we are using here AND gate. So here for y3 input, this is E into a1 into a0. So here we have two inputs, a1 and a0 lines and enable signal line. So enable is common for all the outputs. So we are giving this signal to the all the gates, enable. Okay. And for y3 we have to give a1 and a0, this AND gate. So one signal is here we are getting a1 and another one is this we are getting a0. So we if the inputs for the first AND gate here is a0 into a1. So we are going to get the product term E into a1 into a0, that is the output as y3. Okay. For y2 here we have to get E into a1 into a0 bar. Okay. So here to get the a0 bar and a1 bar, we have to give these a1 and a0 inputs to the NOT gates. Here we are going to get the a1 bar and here we are going to get the a0 bar. Okay. So for to get the y2, the inputs for the AND gate is a1. So here we are getting from a1. This is the input from a1 line and a0 bar. So a0 is given to the NOT gate. So we are going to get the output from the NOT gate is a0 bar. So this a0 bar is given to the AND gate. This is a0 bar. Okay. So then we are going to get the product term E1, a1 into a0 bar. So for y1, here the product term is, min term is into a0. So here one of the input is E for this AND gate and we have to get a1 bar and a2 bar. So a1 bar is from here. So this is a1 bar and a0 directly we are getting from a0 line. So this is a0. So E, a0, a1 bar are the inputs to this AND gate. So we are going to get product term as C, a1 bar and a0. Okay. And for y0, it is E, a1 bar into a0 bar. So here, this is the input line, a1 bar and this is we are going to get from a0 bar and this is enable signal is for this AND gate. The product term we are going to get is E, a1 bar, a0 bar, that is y0. So like that we have to convert the Boolean equations into logic circuit diagram by using logic gates. So this is the logic circuit for 2 to 4 decoder. So next one is 3 to 8 decoder. Okay. So for 3 to 8 decoder, normally decoder has n inputs and 2 to the power of n outputs. So here n is equal 3. Then how many outputs we are going to get is 2 power 3, that is 8. So 3 to 8 decoder. So for 3 to 8 decoder we have 3 inputs and 8 outputs and 1 enable signal. Okay. So this is the 3 to 8 decoder block diagram. So here A0, A1, A2 are the inputs and enable is the input signal, and Y0 to Y7 are the output signal. Okay, when E is equal to 1, this 3 to 8 decoder will be enabled, and any one of the output is going to be high according to the inputs. So if we observe the truth table of 3 to 8 decoder, so here we have enable signal and inputs are A0, A1, A2 and outputs are from Y0 to Y7. Okay. If enable is 0, then the 3 to 8 decoder will be disabled, then we will not get any output is going to be high, all outputs will be 0. Okay. If enable is 1, the 3 to 8 decoder will be enabled. According to the inputs, any one of the output is going to be high. So if it is 0, 0, 0, if input combination is 0, 0, 0, then we are going to get Y0 will be 1, other outputs are 0. And if it is 0, 0, 1, 0, 0, 1 means in binary code it is 1. So the Y1 will be high and other outputs are going to be 0. If it is 0, 1, 0 means it is 2. Inputs we are giving 0, 1, 0, that is 2. So Y2 will be high, other outputs are 0. If it is we are giving 3, 0, 1, 1, 1, then Y3 is going to be high, other outputs are 0. If it is 1, 0, 0, Y4 is going to be high, other outputs are 0. If it is 1, 0, 1, then Y5. If it is 1, 1, 0, Y6. And if it is 1, 1, 1, Y7. So any one of the outputs are going to be high, other outputs should become 0. Okay. That is the functionality of the 3 to 8 decoder. Okay. So here if we write the equation for Y1, Y0 here. So if we write the equation for Y0, so Y0 will be 1 during A2 0, A1 0 and A0 0 and enable is called high. So we can write that in terms of product term, that is min term A1 A2 bar into A1 bar into A0 bar. So next for Y1 will be high when if we give the combination A2 is equal 0, A1 is equal 0 and A0 is equal 1 and enable is equal 1. So enable. Okay. So here A2 bar and A1 bar into A0. Okay. For Y2 enable, Y2 will be high during the 0, 1, 0, that is A2 bar into A1 into A0 bar. And Y3 is for 0, 1, 1 inputs, we are going to get the Y3 is 1. So enable A2 bar A1 into A0. Okay. For Y4 where we are getting Y4 for 1, 0, 0 combination. So 1, 0, 0. 1, A2 is 1. So we are writing E into A2. And A1 is 0. 0 means we have to write A1 bar. A0 is 0. So we have to write A0 bar. And for Y5, enable. Okay. 5, 1, 0, 1 combination we are going to get Y5 is called 1. So 1, 0. 1 means A2 is 1. 0, A1 is equal 0. That's why we are writing A1 bar. And A0 is 1. Okay. Y6, it is 1, 1, 0. So A2 into A1 into A0 is 0. So we have to write A0 bar. And Y7 is equal into, for 1, 1, 1, 1 combination, we are going to get the Y7 is 1. Okay. So A2, A1, A0. So like that from the truth table, we have to write the output equation in terms of minterms. So we have to convert that Boolean expressions, logical expression into logic circuit by using logic gates. Okay. So here we have the A0, A1, A2. Okay. So here A1, A0, A2 are the input signal, and we have the combinations of the A0 bar, A1 bar, A2 bar also. For that we are giving that signal to the inverter. So here we are going to get A2 bar and A1 bar and A0 bar. Okay. So here for first AND gate, so another signal enable is given to the all AND gates. All AND gates, and here first AND gate Y0 to get Y0, the product term is E into A1 bar, A2 bar, A3 bar into E. So here E we are getting A2 bar and A1 bar and A0 bar, the inputs lines we have to take from these inverters, and the product term we are going to get is enable A2 bar, A1 bar into A0 bar. Okay. For Y1 it is E into A0, A1 bar, A2 bar. So here we are getting from A2 bar, we are taking this one A2 bar, and A1 bar also we are taking, and A0. So this line is A0. So this is A1 E. Like that we have to draw the product terms by using the AND gates, and for that we are going to get outputs from Y0 to Y7. Okay. So Y2 is equal to here E into A0 bar into A1 into A2 bar. So we have to take the inputs from A0 bar. So this is A0 bar. So that's why here we are getting that line A0 bar and A1 and A2 bar. Okay. For Y3 it is enable into A0, A1, A2 bar. So here we have E and A0. So this is the A0 line and A1. So this is the line A1 line. So here we are getting A1 and A2 bar we have to take. So this is A2. So here we are going to get A2 bar. Okay. For Y4 enable A0 bar, A1 bar into enable A0 bar, A1 bar. From A2 we are getting this one. So here it is A2. Okay. For Y5 enable A0, A1 bar into A2. So enable here from this is A0 line, and here this is A0, A1 bar, and this is A2. Okay. And Y6 enable A0 bar, A1 into A2. So enable A0 bar, A1, A2. A1 and this is A2. Okay. And Y7 A0, A1, A2 into enable. So enable, this is A2, this is A1 and this is A0. So if we give these E, A0, A1, A2 to the AND gate, the product term we are going to get is A0, A1, A2, E, that is the output Y7. Like that we have to convert the logical expressions into logic circuit by using logic gates. So here the implementation of higher order decoders by using lower order decoders. So here by using 3 to 8 decoder. So now logic diagram of 3 to 8 decoder we know. By using 3 to 8 decoder, how to construct a 4 to 16 decoder. By using 2 to 4 decoder, how to construct a 3 to 8 decoder, we are going to discuss now. Now let us implement the following two higher order decoders using lower order decoders. So that is 3 to 8 decoder by using 2 to 4 decoder, and 4 to 16 decoder by using 3 to 8 decoder. Okay. So we know that 2 to 4 decoder, if we observe 2 to 4 decoder, it has 2 inputs and 4 outputs. For 3 to 8 decoders, we need 8 outputs. So for that, we have to use another decoder, that is 4 decoder, 2 inputs and 4 outputs. But if we take these 2 decoders, we are getting 4 inputs and 8 outputs. So, but 3 to 8 decoder has 3 inputs only. So, how to convert these 2 to 4 decoders into 3 to 8 decoders, we are going to discuss now. Okay. So, we can find the number of lower order decoders required for implementing higher order decoder using the following formula. The required number of order decoders are M2 by M1. For example, I want to construct 3 to 8 decoder. This is my final decoder to design by using 2 to 4 decoder. Okay. So here, if we observe what is M1 and M2, M1 is the number of outputs for lower order decoder. So the lower order decoder is here 2 to 4. So the number for the outputs are 4. So here M1 is equal 4. Okay. So by using this lower order decoder, I want to construct a 3 to 8 decoder. So 3 to 8 decoder, then it is the higher order decoder. Okay, here M2 will be the outputs of the higher order decoder, that is 8. Okay, then M2 by M1, that is 8 by 4, that is 2. We are getting here, this 2 indicates 2 lower order decoders we are going to use to construct the higher order decoder. So that's why this is the formula to find out the how many number of lower order decoders are going to be used to construct the higher order decoder. So here we are going to use M2 by M1. Here is M1 is 8 because we are going to construct the 3 to 8 decoder. 3 to 8 decoder has 8 outputs, where M1 is the lower order decoder. Here we are going to use the 2 to 4 decoder to construct the 3 to 8 decoder. So the lower order decoder is 2 to 4 decoder. So for 2 to 4 decoder, the number of outputs are M1 is equal 4. So here we are going to get is 2. So here we are going to use 2 to 4 decoders. And for first 2 to 4 decoder, we have 4 outputs and another decoder has 4 outputs. But if we observe the inputs here, A0 and A1 are inputs to the both decoders. Okay, A0 and A1 are the inputs to the both decoders. Here we are going to get A1, A0 and here also A1 and A0. Okay, the third input, the enable signal is used as a A2. So A2 is directly given to the first decoder and A2 bar is given to the next decoder. Okay, so here we require 2 to 4 decoders for implementing one 3 to 8 decoder. This is the block diagram of 3 to 8 decoder using 2 to 4 decoder. So here for to construct the 4 to 16 decoder, 4 to 16 decoder has the 16 outputs and 4 inputs. So here in this decoder, to know the how many lower order encoders are required to construct the 4 to 16 decoder, here we are going to use the 3 to 8 decoder to construct the 4 to 16 decoder. So here M2 will be the outputs of the higher order decoder. So outputs for the 4 to 16 decoder are 16 and outputs for the lower order, that is we are using here 3 to 8 decoder. So M1 is equal 8 outputs of the lower order and M2 is the outputs of the higher order. So M2 by M1, that is 16 by 8, that is 3 to 8 decoders we are going to use to construct the 4 to 16 decoder. So how to implement a 4 to 16 decoder by using 3 to 8 decoders? Here normally 4 to 16 decoder has the 4 outputs A3, A2, A1, A0, okay, and 16 outputs, y15 to y0. Okay, so we have to construct this 4 to 16 decoder using these 3 to 8 decoders. Okay, so for that, these three A0, A1, A0 are both inputs for the two decoders, 3 to 8 decoders. So here we are getting A2, A1, A0, A2, A1, A0. Okay, so the enable signal is act as directly to the 3 to 8 decoder. Here A3 bar act as enable for the second 3 to 8 decoder. Okay, so first 3 to 8 decoder, the outputs are from Y8 to Y15 and second order Y0 to Y7. Okay, so if you observe the truth table 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0 up to 0, 1, 1, 1. Next off we are going to get 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0 up to 1, 1, 1. If we see this line, this is 0 and next off it will be A3, A2, A1, A0. A3 will be 0 for first off and A3 will be 1 for next off inputs. Okay, and these combinations are going to be repeat 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0. So these combinations are going to be repeated here. That's why we are giving A2, A0, A1, A2 are both inputs for the two decoders, and for first off, here first of inputs A3 will be 0. That's why we are getting not gate here we are using. Here we are going to get A3 bar. And for next off, this A3 is 1. That's why directly I am giving A3 to the first decoder. So this is the implementation of 4 to 16 decoder by using 3 to 8 decoders. So application of decoders here. These decoders are used for code converters used in the memory system of computers to access a particular memory location. So to access the any one, because decoder application is any one of the output is going to be high according to the input. So to access the any particular memory location, we are going to use this decoder based on the address produced by the computing device. To carry out the operation in the ALU, arithmetic logic unit of CPU, decoders are used to decode the program instructions to activate the control lines. So next we are going to discuss about the what is till now we discuss what is decoder. Now we are going to discuss about the what is encoder. So the combinational circuits that change the binary information into n input lines are known as encoder. So here in encoder, okay, here we have 2 to the power of n inputs and we are going to get the n output. So it is going to change the binary information into n output lines are known as encoder. So the binary information passed in the form of 2 to the power of n input lines. The output lines will be encoded into n bit code. Okay. So encoder is the function is reverse operation of the decoder. So at a time only one input line is activated for simplicity. So the produced n-bit output code is equivalent to the binary information. Whatever the 2 power n inputs are given, n outputs we are going to get. These n outputs are the binary information for the n input 2 to the power of n input code. So this is the block diagram of the encoder. We have 2 to the power of n inputs and n outputs. Okay. So we have if n is equal n 2 to the power of n inputs to n outputs. So if n is equal 2 means 4. 2 power 2 is 4. 4 to 2 encoder we have. If n is equal 3, 2 power 3 8. 8 to 2, 8 to 3 encoder. If n is equal 4, we have 2 power 4 16 to n is equal 4. So 16 to 4 encoder. We have like this we have encoders 4 to 2, 8 to 3, 16 to 4 encoders. So if you observe the 4 to 2 line decoder, Okay, so here for that we have 4 inputs and 2 outputs. 4 inputs are for y0, y1, y3 and outputs are a0 and a1. Okay, so if in 4 input lines, one input line is set to true at a time. Only one input will be set high during the input. So if y0 is 1, other inputs are 0. If y1 is 1, other inputs are 0. Only one input line is set to true at a time to get the respective binary code in the output side. So below are block diagram of the A4 to encoder and its truth table. Here in 4 to 2 encoder, 4 inputs we have y3, y2, y1 and y0, and a1 and a0 are the outputs. So if you observe the truth table, so only any one of the input should be high. But for that only we are going to get its binary code in the output. If it is D0 is 1 means we are going to get 0, 0. If D1 is 1 means we are going to get 0, 1. So here 1 index. So here we are that will be come as a binary code at the output 0, 1. If D2 is means 1, 0. If D3 is equal 1 means 1, 1. Okay, if none of the inputs are going set to high, then outputs is going to be indeterminate. So if you observe this truth table, okay, here where we are going to get the outputs means here. So if we observe the outputs y3, y2, y1 and y0, a1 and a0. Okay, so 0, 0, 0, 1 we are going to get the output 0, 0, 0, 0, 1, 0 we are going to get 0, 1, 0, 0, 0, 1, 0, 0. If y2 is equal 1 we are going to get 2, 1, 0, 0, 0, 1, 1. Okay, so this is the truth table of the 4 to 2 decoders. If we observe the output combination, so a0 is 1 when y1 is equal 1 and y3 is equal 1. Okay, so we can directly write y3 plus y1. So y3 plus y1. So a1 is equal 1 during y1 is equal 1 and y3 is equal 1. So we are writing y3 plus y1. a1 is equal 1 during y2 is equal 1 and y3 is equal 1. So y2 plus y3 we are writing this output equations in terms of input. So place means we are going to use OR gate here. So y3 and y1 are inputs to this OR gate. So here we are going to get y3 plus y1, that is a0, and here y3 and y2 are the inputs for this OR gate. Here we are going to get y3 plus y2, that is a1. So we are converting logical expression into logical circuit diagram by using equations. So if you observe 8 to 3 encoder, we have 8 inputs, that is from y0 to y7, and outputs are a0, a1, a2. According to the any one of the input is going to high, only one input should be set to high. We will get the particular binary code at the output. Okay, this is functionality of the 8 to 3 encoder. So if we observe the truth table, so if y0 is equal 1 means input line y0 is equal 1 means this 0. So we are going to get 0, 0, 0. y1 is equal 1 means 1. y2 is equal the particular binary code we are going to get in the output 0, 1, 0. Encoded as a binary code. y3 is equal 1 means 0, 1, 1. y4 is equal 1 means 1, 0, 0. y4 is equal y5 1, 0, 1. y6 1, 1, 0. y7 1, 1, 1. So if we want to convert this truth table into logical expressions, see A2 will be 1 during y4 and y4 and y5, y6 and y. So we have to write that as y4 plus y5 plus y6 plus y7. And A1 will be 1 at y3, y4, this y2, y3, y6 and y7. During these inputs only A1 will be I. So we can write A1 is equal y2 plus y3 plus y6 plus y7. And A0 will be 1 during y1 is equal 1 and this y3 is equal 1 y5 is equal 1 and y7 is equal 1. So y7 plus y5 plus y3 plus y1. So we are converting this truth table into logical expressions. That is the relation between the outputs and input lines of 8 to 3 encoder. So here we are giving the converting in the logical expression into logical diagram here. So here we are going to get A2 is equal y7, y6, y5, y4. Okay, we are giving inputs here. So here we are going to get y4 plus y5 plus y6 plus y7. Okay, for A1 we are giving y7 and y3, and this line is coming from y6 and this is from y2. So here it is, we are giving to the OR gate, so the input lines will be added here, y2 plus y3 plus y6 plus y7. Okay, here we are going to get y7, y5, y3 and y1. So this is y1 plus y3 plus y5 plus y7. Okay, this is 8 to 3 encoder logic circuit. So here we studied about the encoders and decoders. Here in the drawback of encoder is, here there are an ambiguity when all outputs of encoder are equal to 0. So if all outputs of encoder are equal to 0, because it could be the code corresponding to the inputs, when only least significant input is 1 or when all inputs are 0. Okay, if more than one input is active high. So we discussed till now, encoder is nothing but any one of the input should be set to true, then corresponding binary code will be encoded at the output of the encoder. But if we have more than one inputs are going to be high, then we are going to get the error. So if more than one input is active high, then the encoder produces an output which may not be correct code. So that error code we are going to get the encoder output. For example, if you have both lines y3 and y6 both are high, okay, then encoder produces 111 at the output. Okay, so that is error output we are going to get the encoder if more than one inputs are going to be set high. So to avoid that one, we are going for, to overcome that the error code, these difficulties, we are going for priority encoder. So we should assign priorities to each input of encoder according to the priority, that particular highest priority input binary code we are going to get the encoder output. So the output of the encoder will be binary code corresponding to the active high inputs when which has higher priority. Okay, so this encoder is called as priority encoder. The difference between encoder and priority encoder, in encoder only one input should be set to be high and other input should be 0. If we have more than one input or high, we are preferred to go for priority encoder. According to the priority given to the input, the corresponding binary code will be generated at the encoder. So here we are going to discuss about the 4 to 2 line priority encoder. Here 4 to 2 line priority encoder, same block diagram, we have 4 inputs for y3, y2, y1 and y0. Outputs are a1 and a0. But here we have more than one input may become the high, set to high. The corresponding highest priority input binary code will be generated at the output. So you see here x, here if all inputs are 0, we are going to get a1 and a0 are don't care condition. So that is b is equal 0. That is, so b signal is valid. The output is valid or not. If we get xx, the output don't care condition, the output will be, it's not valid output because any one of the input is not set to high. Okay, if y0 is equal 1, then the priority is given to the y0 only, then we are going to get output 0 0. Then it is a valid signal. That's why v will become 1. If y1 is equal 1 and y0, whether it may be 1 or 0. If it is 1, if both inputs y1 and y0 both are 1 also, the priority is given to the y1 only. Okay, then the corresponding binary code for y1 is 0, 1 that will be generated. If y2 is 1 and y1 and y0, it may be 1 or 0, y0 may be 1 or 0. If both are 1 also, y1 and y0 are 1 also, the priority is given to the y2. So the corresponding binary code 10 is generated at the output. If y3 is 1 and irrespective of y2, y1, y0, if y2 may be 1 comma 0, it may be 1 or 0, it may be 1 or 0. If it is 1 also, the priority is given to the y3. So the corresponding binary code 11 is generated at the output. So this is the priority encoder. If more than one inputs are set to high, then the priority encoder is preferred. So the truth table for the priority encoder. So from the truth table we have to write the K map here. Okay. So it is for 4 inputs. We have 16 combinations. So here, because it may be 0 or 1, so 0, 0, 0, 1, 1, 1, 1, 0. So for that, we are going to get equations y3 plus y2 and y3 plus y2, y1. See here, if we observe this truth table, it may be 1, 1, 0 or 1, 0. We have 1, 1 or 1, 0. For both combinations, A0 will be 1. Okay. And if we have observed this 1, A1 is called 1 during 1, 0, 0 or 1, 0, 1, 1, 1, 0 or 1, 1, 0, 1, 1, 1. So during that combination, A1 is 1. So if you observe this A1, we have this 4 input combination. So in this x may by 2x is x, it may be 1 or 0, it may be 1 or 0, it may be 1 or 0. During that time, you are going to get output is 1. So you have to write where you are going to get output as 1 and note down this. If we observe the group, we can make this one, another group for product term is this one. So here we can write this as, okay, here we can write this as y3 because y2, because here it is the common y2. Both these are changing, so we can write that as y2. And for this term, we can write this as y3 plus y2. And A0 also, if we write the K map, so for all combinations, here we are going to get this one we make one group and another group is this one. Okay, if this one we can write the term product term is y3, literal y3, and for this we are going to get is here common is 1, that is y1. In this common term is in both 0, 0 and 1, 0, 0, 0 we have, so that is y2 bar. So A0 is equal y3 plus y1 into y2 bar. Okay, so this is the priority encoder equations A1 and A0. We have to convert that into logic circuit by using gates here. So what are the equations we are going to get is A0 is y2 plus y0 and A1 is y3 plus. So here for A1 we are going to get is y3 plus y2 and A0 we are going to get is y3 plus y2 dash into y1. Okay, for y3 and y2 we are giving to the OR gate because we are adding these two inputs, so we are giving to the OR gate. So we are going to get output is y3 plus y2. Whereas A0 that is y3 plus, okay, so here we are going to get y3 plus y2 bar into y1. Y2 we are giving to the inverter, so we are going to get here y2 bar and y1. So we are giving to the AND gate, here the product term is y2 bar into y1. So we are adding this to y3 plus y2 bar by using OR gate. So here we are going to get y3 plus y2 bar into y1. Okay. So V is 1 for all y0, y1, y2 and y3 is 1. So that's why we are giving to the OR gate. This is the priority encoder logic circuit. 422 line priority encode logic circuit. So advantages of priority encoder logic circuit is these systems are very easy to use in all digital systems. Encoders are used to convert a decimal number into binary number. So this is one of the advantage of encoder, and our objective is to perform a binary operation such as addition, subtraction, and multiplication. Also, we are going to use the encoders. So these are the references books. So R.P. Jain by Modern Digital Electronics and John F. Fackerly. The Digital Design Principle and Practices by John F. Fackerly. The circuit diagrams and truth tables are taken from the electronicstutorials.com and electricalacademia.com and tutorialspoint.com.
Like, share and subscribe. Hit the bell icon for more updates.